Dear students, good morning to all. I hope all are fine. Today we discuss about, you see in detail, exercise 5.5. In this exercise, we discuss about the practical problems in this unit, analytical geometry. The analytical geometry, we have already discussed the parabola, ellipse and hyperbola. So here in this exercise 5.5, we see some of the problems in day-to-day life. Day-to-day life, we see some of the problems. So sum number 1. A bridge is in the shape of a parabola. A bridge is in the shape of a parabola. And height is the center 10 meter. Height in the center is given 10 meter. Wide is given 30 meter. Height of the 10 meter and wide is 30 meter. Find the height of the arch 6 meter from the center. 6 meter from the center. We know that this is mine. There are 4 types of parabola already we discussed about here. So we use the general definition of the parabola, open right angle parabola, and its equation is y square equal to 4ax. Here, the bridge is in the shape of the parabola. So let me assume that it is not a shape of the bridge. So for arch it is in the shape of a like this. Like that. So let me assume that the arch of the shape is like this. So what is it here? It is a downward parabola. Let me consider it is a parabola, downward parabola. Let me assume that the parabola, downward parabola. So first of all, the downward parabola. Let me assume that the downward parabola. Okay, the bridge is in the shape of the parabola. The given height of the parabola is 10 meter. The wide is 30 meter. And we need to find the height of the arch 6 meter away from the center. So let me assume the parabola is a open downward parabola. So the solution. From the given details, listen here, the bridge is in the shape of the parabola is given. Bridge is in the shape of the parabola is given. Height is 10 meter in the middle. The center and the height is 10 meter. Wide is 30 meter. We need to find the height of the arch 6 meter away from the center. So let us given details, let me assume the parabola is open downward. So the diagram is like this. The diagram is like this. We assume that the parabola x square equal to minus 4ay. X square equal to minus 4ay. This is the equation of the parabola for all open downward parabola. This is the equation of the parabola for all the parabola open downward. Let me need to find equation of our parabola. Let me need to find the equation of our parabola. So what is it here? It is the equation number 1. It is the equation not for our problem. It is a general equation of the parabola. Whatever it is open downward, it is the parabola x square equal to minus 4ay. So for next, let me assume that vertex is like this. Vertex is like this. It is the y-axis and it is the x-axis. It is the y-axis and it is the x-axis. So what is the vertex 0, 0. Vertex 0, 0. And height of the parabola is 10 meters given. Height of the parabola is 10 meters. Let me assume the line is like this. Let me assume the line is like this. Let me consider these as equation of the Laplace rectum. The line of the Laplace rectum I should we consider here. So what is it here? The middle line is a 10 meter. And the wide is a 50 meters. Here given total wide is a 30 meters is given. In fact, this side 50, this side 50. Let me assume the point in this side. What is it here? Minus 15, minus 10. Here, plus 15, minus 10. Plus 15, minus 10. Here, because the height is here, it is the x-axis. The downward values is negative values. So the right hand side it is a positive, so we put it as a 15 plus 15 minus 10. Here minus 15 minus 10. So today substitute the points. equation 1 passing through, equation 1 passing through point, let me assume the point 15 comma plus 15 comma minus 10. The equation always passing through, that is the parabola passing through the vertex A, B. The 3 points is passing through this at this level. So we are able to substitute A or B. If suppose we substitute the values of B, we got the answer. Because of both the sides we got it as 0. So then equation 1 passing to the point B, that is 15 comma 10 and then minus 10. So substitute the values here, 15 square equal to minus 4A into minus 10. Then 225 by 10 equal to 4A. What is the value? 225 by 10 equal to 4A. Then equation 1 becomes, what is it here? X square equal to, x square equal to, the value of 4A is here, 225. And I am minus 225 by 10 into Y. X square equal to minus 225 by 10 into Y. So this is the equation for our problem. This is the equation for our problem. Let me answer the equation number 2. Next we need to find the height of the arch 6 meters away from the center. So that is, here the length is 50 meters. So we need to find the height either left hand side or right hand side. Either left or right. So to 6 meters away, let me assume the line is like this. So what is it here? A, I will give you A, B. Here let me assume that the point is C, D, the point is E next to. Let me consider the point as E. So what is it here? We need to find the height, that is CD. And we need to find the height CD. So let us assume the point B, 6. Let us say 6. Y unknown values, let me put it as a Y1. Y1 is assumed by 4. So let us substitute the points. It passes through. Equation 2 passes through. And the point then is 6 comma Y1. The point B, 6 comma Y1. So what is it? We substitute the values here, 36. 6 square 36 minus 225 by 10 into Y. Y becomes Y1 here. So 360 divided by 225 equal to Y1. That is a minus here. So then the Y1 becomes Y1 equal to minus 1.6. We got in the values. Y1 is minus 1.6. That is the DE, the length D equal to 1.6 meters. But we need to find the value of the CD. So therefore, CD equal to, what is it here? CD minus DE. C value is 10 minus 1.6, that is 8.4 meters. The height of the bridge 6 meters away from the center is 8.4 meters. Are you understand, students? Right. Listen, students. Sum number 3. At a water foundation, water attains maximum height of 4 meters at horizontal distance 0.5 meters. So let me assume that it is a ground. A is the position of the what is the fountain. A is the position of the fountain. The water flow is like this. It attains maximum height 4 meters. It attains the maximum height 4 meters in 0.5 meters. So 0.5 meters, the horizontal distance, it attains maximum height 4 meters. If the path of the water is a parabola open downward and originating at the origin, find the height of the water at the distance, horizontal distance 0.75 meters. We need to find the height at the 0.2, and the remaining 0.25. We need to find the height of the water at that place. Right? Listen, man. Let me assume that the given details is clearly here. It is a open downward parabola. So the general equation is going to be x square equal to minus 4ay is the general equation of the parabola for all parabola open downward. General equation of the parabola, for all the parabola open downward, equation is x square equal to minus 4ay. Understand? Listen here. This is the given details. If the origin is given like this, here it is the water issuing point is the origin. The detail is given like this. What is the detail? Let me assume the diagram. Here the diagram is like this. It is the water issuing point A. Let us assume that the point A. Let us given it is A 0, 0 Next, the position. Water flow is like this. Water flow is like this. Water flow is like this. This is the point A. This is the point. Let me assume that it is the maximum height at 4 meters. Maximum height at 4 meters. So, 4 meters, actually it is a 4 meter. At the distance 0.5 meters away from the starting point. 0.5 meters away from the starting point. The maximum height is 4 meters. Let me assume that the vertex is like this. Let me assume that the vertex is like this. It is a capital X axis and it is a capital Y axis. Capital X axis and capital Y axis. So, understand or not? So, what is it here? It is a general equation. If a general equation is really converted, vertex is not at all origin. In a vertex, vertex is first of all, I will not be converted the equation as like this. What is it here? X minus x is the whole square equal to minus 4a into y minus k. If each vertex is h comma k. Each vertex is h comma k. First of all, we need to find a vertex. Vertex, let me, vertex. What is it here? This is 0.5 meters. 0.5, comma, height of 4. 0.5, 4. Let me assume the vertex is 0.5, 4. Then the equation becomes, let me assume that the equation 2. So what is that here? X minus 0.5 the whole square equal to minus 4a into y minus 4. K value is 4, y minus 4. This is the equation for the given details. This is the equation for the given details. Whatever the values b is given, in the previous problem vertex is the origin, but here the vertex is another one point. Vertex is another one point. Next we need to find the height. We need to find the height. We need to find the height of the water at 0.25, that is 0.75. Here 0.5 that times is maximum height 4 meters. After that, the water will flow in downward direction by gravitational force. By gravitational force, that is the total at 0.75, that is starting from the starting 0.75 meters, we need to find the height of the water. So what is it here? Above the point, let me assume that the point. What is it here? 0.5. You know, 0.25, that is 0.75. The length is here 0.75. And that is 0.75. Comma 0. This is the point. Let me assume that the point is already we put it as A. Here we put it as A. The equation 2 passes through the point A, vertex 0, 0. That is substitute the value 0 here. So the 0 minus 0.5 whole square equal to minus 4A into 0 minus 4. 0 minus 4. So the minus and minus plus 6. That is 0.5 whole square becomes 0.25. 0.25 equal to 4A into 4. That is 4A equal to 0.25 divided by 4. 0.25 divided by 4. Then the equation 2 becomes, what is it here? X minus 0.5 the whole square. X minus 0.5 the whole square equal to the values of 4A is, the values of 4A the values of 4A is 0.25 by 4. 0.25 by 4 into y minus 4. Into y minus 4. Into y minus 4. That is, we need to find the height at the distance 0.75 meters. At the height 0.75 meters. That way, we consider the point as 0.75 comma y1, 0.75 comma y1. So we need to find the height at the point. So to substitute the points, 0.75, it passes through. It passes through 0.75 comma y1. 0.75 comma y1. 0.75 minus 0.5 whole square equal to minus 0.25 divided by 4 into y minus 4. So therefore what is it? We have 0.25 the whole square. 0.25 the whole square. 0.25 by 4 into y minus 4. So you can so minus it in. So therefore what is it? 0.4 by 0.25 cancel. 0.25 into 4 equal to minus y minus 4. That is 1 equal to, that is 1 equal to 0.25 into 4, that is 1 equal to minus y minus 4. Y minus 4, so minus 1 is equal to minus 1 minute. Minus 1 equal to y minus 4. Minus 1 equal to y minus 4. Then minus 1 minus plus 4 equal to y. Minus 1 plus 4 equal to y. That is y equal to 3. Y equal to 3 meters away. That is the height of the water flow is 3 meters. Height, the distance 0.75 meters. So by reading again, the water flow in the horizon, the flow is an open downward parabola, like an open downward parabola, and the height 4 meters from 0.5 meters from the starting point. Here we need to find the height of the water at 0.75 meters from the starting point. Here you understand that? We need to find the height of the water at 0.75 meters from the starting point. Isn't that? Open downward parabola is given, that is x square equal to minus 4a. What is the general equation of all the parabola, open, downward? And your vertex is not at all horizontal. Because vertex clearly is given, starting point is the horizon is given. So no need to consider the vertex as the horizon. Because they are given, vertex is not at all horizontal. So let us assume the vertex x comma k means the equation of the parabola is changed here, that is x minus x the whole square equal to minus 48 into y minus k. Then we assume that it passes to the point 0, 5, 4. 0, 5, 0.5, 4. Vertex is 0.5, 4. However, it is the maximum height attained by the water. After that, the flow of the water is downward. It is the power of the water flows upward. It reaches its maximum height at 4 meters. Then the flow of the water is downward to due to the gravitational force. So therefore, the x value is 0.5, y value is 4. We apply the x minus 0.5 whole square equal to minus 48 y minus 4 the whole 4. Minus 4. It passes to the point a 0, that we substitute the values a 0, and we got the values as a. So that's why we consider here a 0, passing to the point. So 0 minus 0.5 the whole square equal to minus 4 into 0 minus 4. Now 0 minus 5 the whole square becomes 0.25. 0.25 equal to 4 into minus plus 4 into 4a into 4. So we take out the values such as 4 is a dominant here. 4a equal to 0.25 by 4. So substitute that values 4a in the equation 2. We replace the 4a and substitute the value 0.24 by 4 here. And this x minus 0.5 the whole square equal to minus 0.25 by 4 into y minus 4. Into y minus 4. It passes to 0.75 comma y1. Because that is we need to find the values of the height. In the previous problem, it is the downward of the x-axis, but here it is the upward of the x-axis. So we take down the points of the directly, we need to find the height. Let us assume that the point is the C millimeter. We take down the values of the height CP. We need to find the height CP. So by assuming the point B 0.75 comma y1, so that is 0.75 minus 0.5 whole square equal to minus 0.25 by 4 into y minus 4. So substitute the values here. So the minus 4 that is 0.25 equal to 0.25 by 4 y minus 4. The minus already present here. 0.25 here also 0.25 cancel here. 0.25 into the cross multiplication 4 comes to here. 0.25 into 4 minus y minus 4. That is 1 equal to minus y minus 4. The cross multiplication 1 equal to minus 1 equal to minus y minus 4. Minus 1 plus 4 equal to y equal to 3. That is the height of the water from the starting point to the 0.75 meters is 3 meters. The water at the height of 0.5 meters distance is 3 meters. Similarly, this is another question we are able to ask this: at what distance it appears the ground? At what distance it appears the ground? Okay, we are able to answer so many types of the questions. If suppose the creative questions ask this, if suppose the point is P, 0.75 meters is given. So next they are asking, at the distance of 1 meter, we need to find the height of the water, or otherwise, at what distance? The distance, if suppose the distance is given, distance our same distance we need to find the height. If suppose distance, anywhere the question asking here, you are ready to answer it. So it is the easiest method. First of all, we conclude the given equation which type under. It is a open upward, downward, or anyhow. So we need to find it first of all. After that, apply the points. We need to find a particular equation of the parabola. After that, we apply the known values and we need to find. Dear students, the same type of the problem, sum number 8. So first of all, we discuss about the parabola type of the problems. So the first sum is over. Next, it is the sum number 8. It is also we discuss about the parabola. In this sum, the given that, let me assume the diagram is like this. It is a ground. Let me consider it is a ground. It is a ground. Water is issuing that like this. Water is issuing that like this. The water pipe with a height of 7.5 meters from the ground. 7.5 meters from the ground. So, but listen here, it is a delivered position of the pipe. It delivered the water. It is in the shape of the arch, like a parabola. It is in the shape of the arch, like a parabola. It's a ground. It strikes in the ground. If suppose it is a very less power, means it blow like this. If little bit power means this is a shape of the water flow is like this. Let me assume that the water flow is also like this. Let me consider it as a parabola. So from that, let us consider like a previous problem. Let us consider it is a open downward parabola. So open downward parabola general equation is x square equal to minus 4ay. X square equal to minus 4ay is the general equation of the parabola. I understand that x square equal to minus 4ay. So the first concept is finished. The height of the pipe is 7.5 meters. And next one detail is given. That is, at the depth of 2.5 meter, the water will flow 3 meters away from it. We need to find the flow of the water in the ground, the place of touching the earth. Let us assume that the point A to B is seaward flow. Let us assume that it is a seaward flow. So let me assume the diagram is like this. So here the diagram will come. Listen, man. It is the diagram like this. It vertex at the origin 0, 0. It is a sum any point. Sum of any point. Let us assume that it is a 2.5, 3. Like this. I draw a line there like this. That is, we need to find the ground striking distance. That is B. Distance is unknown, x1. The height is 7.5. Height வந்து 7.5. இங்க நமக்கு என்ன சார் height வந்து 2.5. Height வந்து 2.5. Length வந்து 3 meters away from each. So these are given details. In the given details, we need to substitute. This is the general, already I told you, this is the general equation for all the parabola up and downward. Let me consider this is the passing through equation 1. Equation 1 passing through the point A. Passing through the point A, 3 comma minus 2.5. 3 comma minus 2.5. 3 comma minus 2.5. Substitute 3 square equal to minus 4a into minus 2.5. So substitute 9 divided by minus minus plus 2. About 4a divided by 2.5. 9 divided by 2.5. This is the values of 4a. So substitute the values of 4a in equation 1. That is equation 1 becomes x square equal to 4a. 4a values are 9 is already here. 4a values is what is it here? 9 divided by 2.5. 2.5y. 2.5y. This is here. That is the values of 4a alone. The values of 4a is 9 by 2.5. Values of 4a is 9 by 2.5. Next, we need to find the water strikes in the ground at what distance. Right? The distance of the water strikes in the ground. So let me assume that this is the first point is over. This is the equation of the parabola for the given details. This is the equation of the parabola for the given details. This is the general equation of the parabola for all the parabola up and downward. Are you understand? Next we substitute the values d. So what is it here? Equation 2. Equation 2 passes through. Equation 2 passes through. And again the point b. The point what is it here? x1 comma 7.5 minus 7.5. So let me substitute the values x1. x1 is equal to x square. That is x1 square equal to minus 9 into 2.5. Why do I use minus 7.5? So by cancel 3. So minus and minus plus x1 square equal to 9 into 3. You put it as a 9 into 3 like this. Because x1 square value is 9 into 3 becomes, that is x1 equal to 9 root at we get it as 3 root 3. We put it as easily, we can put it like this. So x1 equal to 3 root 3. x1 equal to 3 root 3. So that is the distance of the water strikes in the ground is 3 root 3. So simply we never judge the values is that is 2.5 meters downward, it is 3 meters away. The remaining is here 5 meters. So that is the total is a 3 portion. We divided into 1 portion, it is a 2 portion. So but simply we are asking blindly, some of them saying, sir here 3, another 3, another 3, 9 values, 9 meters away from that. Not that. It is a 3 root 3. Root 3 values we know that 1.7 kg. So it is around 5 something. The values is around 6, near to 6. That is x equal to 3 root 3 values is. We need to find, that is x equal to, no need to find the values root 3, 1.73, no need to substitute the values. It is the x1 equal to 3 root 3 meters. Simply we put it as 3 root 3 meters is enough. So listen, students, again I explain it. The given parabola is in the shape of a semi-parabola. It is a given parabola is the shape of a semi-parabola. Let me assume that it is a full parabola. So that is height is 7.5 meters and 2.5 meters downward it is 3 meters away. We need to find that water striking the ground at length. At what length? So listen here. Let us consider the up and downward parabola x square equal to minus 4ay. It is the parabola for all up and downward parabola. So let us passing through the point. It is a passing vertex and the point A and the point B. So first of all, we substitute the points A. No need to substitute the point B. Because B is the unknown values, A is the known values. We know the values. We need to find the values from known to unknown. From the known to unknown. So if suppose direct substitute means we never get anything because both the equations are equal. That is 0 equal to 0. So we substitute the values here. We got the values 952.5 equal to 4. You no need to divide it. Because the another value is 7.5. You are easily cancel it. So the x square equal to minus 9 by 2.5 into y. Then equation 2 passes through. Substitute pandrom. We got the values x1 equal to 3 root 3.